you by thesis123.com. I learn and teach online.
Here's the next question, number 46. In a linear two-port network, when 10 volts is applied to port 1, a current of 4 amps flows through port 2 when it is short-circuited. When 5 volts is applied to port 1, a current of 1.25 amps flows through a 1 ohm resistance connected across port 2. When 3 volts is applied to port 1, the current through a 2 ohm resistance connected across port 2 is dash. Okay, so we have a lot of information here. So let's write down what's given to us first and then start working on it. So the given information, we have first been given that the voltage V1 is 10 volts. When it is applied to port 1, a current of 4 amps flows through port 2, which means I2 is equal to 4 amps. Now that's the first case. The second case says that 5 volts, when V1 is 5 volts, a current of 1.25 amps flows through a 1 ohm resistance connected across port 2, which means I2 is 1.25 and resistance across port 2 is 1 ohm. Third case says that when 3 volts is applied to port 1, so V1 is 3 volts now, the current through a 2 ohm resistance R2 is 2 ohms and we are supposed to find out what is I2. This is what's given to us. Now you know what are the general two-port network equations in terms of current and voltages. So we have I1 is equal to Y11 V1 plus Y12 V2 and we have I2 is equal to Y21 V1 plus Y22 V2. So these are the two general equations, or in other words the Y parameters. In terms of the Y parameters, these are the two current equations. Now since the question tells us to find out the value of I2, let's use this second equation here. This is the equation we are going to use in order to solve the problem. So when port 2 goes through a short circuit, because here it says that when 10 volts is applied, a current of 4 amps flows through port 2 when it is short circuited. So I'll write that down. When port 2 short circuits, V2 is equal to 0. So when V2 is equal to 0, we can find out what Y21 is. This term becomes 0. So let's substitute that. We will have Y21 is equal to I2 divided by V1. I2 divided by V1. So this gives us the first case. We use the first case here. So that's 4 amps and 10 volts. So 4 divided by 10 gives us 0.4. So here Y21 parameter value is 0.4. Now we use the second case. The second case we have our values as V1 5, V2 1.25 and R2 is 1. So let me just write this down here. We'll write down for the second case. For the second case, we have, I'll write down the equation again first. I2 is equal to Y21 V1 plus Y22 V2. We have our values for the second case as V1 is equal to 5, I2 is equal to 1.25 and R2 is equal to 1. We also found out the parameter value Y21 is equal to 0.4. Now let's substitute all of these values into the equation and find out what is the value for Y22. So here we have I2 is 1.25 is equal to 0.4 into 5 plus Y22 into, now V2 is nothing but I2R2, multiplication of these two, which is 1.25. Now solving for Y22, let's see, now this is 1.25 minus 2 divided by 1.25, that gives us minus 0.6. Okay, so now we have the value of Y21 and we also have the value of Y22. Next, let's find out for the third case, for the final case. For the third case, we have our values. V1 is 3 volts. The current I is what we are supposed to find, and R2 is given as 2 ohms. Now from these two we can say that V2 is equal to 2I2, since V2 is I2 into R2, 2I2. Now let's substitute all of this into the equation. I2 is equal to Y21, which is 0.4, into V1, which is 3, plus minus 0.6 into 2I2. Now if we solve this for I2, we'll obtain a value of 0.545 amps. Well, this is the final answer, 0.545. Well, this is the entire solution and I hope it has made sense.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.